Okay, we continue doing and dealing with the exam questions. Now we have, since you went to school, actually, you learned now most of the theories. So from here, we just we'll do more of questions now, since you already know the theories. Yeah, of course, we'll have time to explain the theories whilst dealing with questions as well. So you have much work to do. It's better we start as soon as possible so that we can finish on time. So this is the paper that we have for today, and I want us to consider the concept that I want to share is on question number 2, and this is question number 2. Mr. Joachim, sir, read for us question number 2A. Are you able to read for us question number 2A? Oh. Go ahead.
I'm saying on my end, I can't see the screen.
You can see the screen? Oh. Is it the same with everyone? Or others can see it?
I can see it on my end.
Yeah. So maybe you will log out within a minute and join. Yeah, I'm sure it should be from your end. Because the question is very much clear. Yeah. So we have this set of questions. Such questions are very nice. You need to do more of them, and then you'll be fine. Okay. Mr. Manza, would you read the question for us so that we try to redeem time?
Okay, you said question 1, question 2, sorry.
Question 2A.
Okay. It leads an economic consultant for X Corp recently provided the firm's marketing manager with this estimate of the demand function for the firm's product.
Okay. Go ahead.
Where is it Q?
Mm-hmm.
I don't know if it's DX or what here now.
You can skip it.
Sorry?
You can skip that part.
Okay. Where Q D over X represents the amount consumed of good X, then PX is the price of good X, then PY is the price of good Y. M is income, and AX represents the amount of advertising spent on good X. Suppose good X sells for $200 per unit, good Y sells for $15 per unit. The company utilizes 2,000 units of advertising, and consumer income is 10,000 US dollars.
Okay.
That's all.
All right. Thank you. So we have been provided with that information and asked how much of good X do consumers purchase. So that is what is there. How do you go about this? There is this consultant for the company who has just provided the company with the marketing, was provided the firm's marketing manager with the estimate demand function for the product that they are selling. And so that's the demand function. And you're given the definitions of what those parameters in the function stand for. They have said that Q superscript D and subscript X represents the amount consumed for good X, where P subscript X is the price of good X and P subscript Y is the price of good Y. M being the determinant and A subscript of X represents the amount of advertising that is spent on good X. So everything has just been defined already for us. So what can we do to find the amount that has been spent on good? You know, how much good X do consumers purchase? How much? So in short, we need the quantity, right? We are looking for the quantity or the amount of good X consumed, which is Q, superscript D and subscript X. How can we find the amount? We just copy the demand function here. Okay. So let's just say Q is 120,000. I don't know. Minus 4px. I think so. Yeah, minus 0.4 m. As 5 a x. Right, that's what we have. And we've been provided with data that the price of X is 200. Okay, the price of good X is what? Is 200. So we get the data here. The PX is 200. What is the price of Y? The price of good Y. How much is it? How much is good Y selling? Hello?
$15 per unit.
So it's selling $15. So we pick, PY equal to 15. And the company utilizes 200 units of advertising. So A loss, A subscript X is equal to, how much is this? Oh, 2,000 units. Then income is equal to 10,000. The income is $10,000. So we now have almost everything that we need. So how can we find Q, right? What do you think we can do from here? Any idea? What can we do from here to find Q?
I think we just replace.
Okay, so we just do the substitution. Okay, so I can say 120,000 minus 4 times where there's P, lower script X is 200, plus 3 times PY is 15 minus 0.4 times M is 10,000 plus 5 times AX is 2,000. Okay, so when you command your calculator, what's the quantity? Let's command the calculator and find how much are we finding?
It's giving me 125,245.
125,245. Someone, are you finding the same? You also correcting.
Let me maybe just try, because some functions is like they were rubbed off.
Oh,
Yeah, so I can't see proper. Let me do.
okay.
I found 1,112,445.
1,112,445. Interesting. Will you do it one more time? Do it again. 120,000 minus 4 times 200. This is 200. Plus 3 times 15. This is 15. Like this one. Times 15 minus 0.4 times 10,000 plus 5, you know, 5 times 2,000.
Yeah, I got 112,545.
Okay. So 125, 245. Okay. At least we have two people finding the same answers. Let's assume that what they are saying is okay. So we can move on to the next part of the question that should be read by Unza. Read for us the next question, number A2, question 2A2.
The one which says how are good X and Y substitutes or complements?
Okay. So what does the class think? Are good X and Y substitutes or complements? Anyone to share insights? How can we go about this one? How can we go about this one? Knowing or deciding whether a good A or X are complements or substitutes. How can we know that? Okay, what do you understand by substitute goods?
Substitute goods are goods that I'll just give an example, like that can be taken in an absence of the other. Maybe instead of eating shima in the evening, you have rice. So even when you don't have mealie meal, you can have rice in shima. Or maybe for breakfast, instead of having bread, if the money is not enough for bread, you can have sweet potatoes.
Okay. Wow. So the substitute goods, according to what she said, they have the same use, right? Yeah, you can interchange them, and they have actually same use. If we say that those same goods are perfect substitutes, then that should actually mean that they can be substituted for each other, like completely. Yeah, and you get the same level of satisfaction. So now, how can we tell if these two goods, this is quantity for good X, by the way. How can we tell whether these are substitute goods or not?
I've just forgot. I don't know whether I'm correct. It's between substitute and complement, there's one where if you get a positive answer, something like that.
Yeah.
I don't know now. I'll confuse the things, but I just know that one of the two, one can be a positive, and the other one a negative, something like that.
Okay, that's it's good that you are able to remember something. But you're hoping in an exam you'll be able to remember everything, not it pains, to just have an idea, but it's not clear. And the time is ticking in an exam. Anyways, so for you to decide whether good X and the Y they are substitutes, you have to look at the behavior or the impact of the price of good Y on quantity of good X. What's the impact, okay, of good Y, or the impact of the changes in Y on price, on the impact of the changes in the prices of good Y and the amount of good X. So what happens to the demand of good X? So for example, you can see that if there are perfect substitutes, if the price of good Y increases, right? If the price of good Y increases, which is the opposite to good, you will see that if they are perfect substitutes, what happens? Is the quantity for good X going to increase, the demand for good X going to increase, or it will decrease?
It will decrease.
It will increase.
What happens? Let's look at what do you think will happen? If the price here, like on PY, increases, becomes big, maybe you put 10,000, or maybe you put 100,000. What will happen to quantity of X? What do you think?
To increase.
The quantity of good X will increase, isn't it?
Yes.
Yes. The quantity of good X will increase because the prices of good Y have increased. Are you able to explain it practically using Zambian example so that people get it? How the substitutes work, like the substitute goods work, when the price of the other related good increases, how does that impact the quantity of the other good?
Can be just to help out on my understanding.
Go ahead.
Yes, so if, for example, good Y, for example, is bread, and then the other one is, for example, good X is maybe sweet potatoes.
Mm-hmm.
So the moment you increase good Y, people stop buying good Y, and they will focus more on the good X, thereby increasing for those who are producing, since X is the one which is on demand, they will increase the production of good X. That's my understanding.
Okay. Thank you for that one. Did you get it? So if you increase the price of good Y, he said, if you increase the price of, let's say, bread, as the prices of bread increase, then people will start doing away with bread and switch to the other one. So you see now the quantities being demanded of the other increasing. Does that make sense, right? Did you get it? Okay. Jinza, you got this one?
Yes, sir.
Okay. So now, how you
Sir,
do it? Yes, sir.
hello.
Yes, sir.
I'm seeing as if it's the same concept with the opportunity cost. Is it not the same?
Yes. Would you explain a bit? Or yeah.
Like the example that he has given of bread and sweet potatoes. When
Yeah.
bread becomes expensive, they'll forego people forego buying the expensive bread and go for sweet potatoes.
Exactly. So
Meaning
you
it's the
sacrifice.
best.
Right. You have it. Yeah. It's about sacrificing, isn't it? You sacrifice this one for the other.
Yes.
Okay. Thank you very much for that, for reminding us of the opportunity cost. We are now in third year. We have forgotten the opportunity cost is from first year.
So,
yeah, yes,
sir,
Chinza. Ma.
so it's so you are saying when the price for good Y the price for good Y increases, the demand for good X increases too.
Exactly.
Okay.
Yeah, the quantities demanded here will increase. Yeah, because you say, this one is expensive, the Y one. So you leave Y and you move to X. So that's what we are trying to communicate. So how you do this one, actually, you use calculus to do that. Do the derivative, dq being the quantity of X, d what? dpy. In short, derive the equation, this function, differentiate the function with respect to py. What's the derivative? What is the derivative? Hello, we are able to derive this function. You remember a bit of calculus, how you do a bit of differential calculus. Do you remember something about calculus from business mathematics?
Yeah, remind me, sir. Remind me just.
You need to be reminded a bit one more time. Okay, this is what we say.
Hello.
Yeah, yes, sir.
So for the 2000, when we are differentiating this whole entire equation, the 2000, since it's just a number, it will become 0.
Yeah, it's a constant. Constant becomes 0, right?
On 0.
Mm-hmm.
Then for any number with a variable in front, it will become that same number, because the variable will always have is it power 0? So any number to the power 0, it becomes 1. So you multiply plus times the 4, which will become the number itself.
Yeah.
I think that's what I remember.
Okay. You are still able to remember math. Okay, thank you very much for that one. So the thing is that when you're deriving the equation like this one, as long as you have a constant, a number that doesn't have, any letter, in this case, it becomes a 0. Okay, so here we'll have a 0. Then here, remember that you are deriving this equation with respect to what? To py, right? So anything that doesn't have py, everywhere where we don't have py, we treat that as a constant. Okay. So here we don't have py, so it will be treated as constant. It will become a 0. Even this one will become a 0 because we don't have py. Even that one we don't have py. So in short, we'll be just concentrating on the positive 3py. So how do you differentiate that? Okay. What will be the derivative of 3py?
It's 3.
Yeah, so it is positive 3, right? How does it become? Like, for example, you remember, let me just give you a simple example of an equation. If you have an equation like this, 3x, using the power rule of calculus, you say that this is raised to the power 1. So you drop the power 1 times this 3 here to the power x to the power 1 minus 1. Remember, the power reduces by 1. So you say 1 minus 1, that will give you 0. So you have 1 times 3 x to the power 0, right? And any number raised to the power 0, you let ma.
Just slightly. You've lost me a bit. I don't know how we've maneuvered towards this to come to
3x.
3. No, not
Okay.
3 before we even go there. Just this, because we say these that do not have py, they are all constants, and then we have remained with a
3py.
3py.
Yes.
So how have you done it now?
Okay. So now, this is what I'm trying to make you understand. I'm trying to show you that how did we come to 3 from 3py? So because the equation now has reduced, it has just become like qx is equal to 3py, isn't it? This is our equation. So I was giving you an example, like it's just as good as you having an equation saying y is equal to 3x, okay? So I was trying to show you that this equation is raised to the power 1. Automatically, we know that. So when you're doing differential calculus, you remember from the basics of differential calculus, we say that when you're dealing with such an equation, you drop the power the way how it is, then you keep the coefficient the way how it is. X 1 minus 1, you reduce, the power by 1. So you have 1 times 3, that will give you 3x to the power what? To the power 0. Then we know that any number raised to the power 0 is what? Is itself. So x to the power 0 will be 1. So that you can take 3 times 1, giving you what? 3. You're following? So this is actually what has happened here. We didn't want to go through all these steps here. 3py to the power. This is just treated as one thing, like py is just as a number, just like x. So this is raised to the power 1. We didn't want to go through all these steps where we start saying 3py to the power 1. You drop the power, it becomes 1 times 3. py to the power 1 minus 1. You know that 3py to the power 0. Then you have 3 times 1. And then you get a 3. This is the 3 that we have gotten. You got it? Did you get it?
So now 3py to the power
1.
1, and then just here down here you've said you've written 3py to the power 0. Is that, isn't it? So
yeah, that's 0. Because 1 minus 1 here, like it would be 0.
Okay. And anything to the power
0 is 1.
Okay.
You got it?
Yeah.
Okay. All right, then we can move on to the next question. So now, the conclusion of the matter is that as long as the derivative is positive, okay, the cross partial derivative, we call this the cross partial derivative, yeah, is positive, then we know that these are substitute goods, okay? If the cross partial derivative is a positive, then we know that these are substitute goods. If it were a negative answer, then we could have said these are what? A complement goods. Okay? Complement goods have a negative answer. Where is it now? Okay. We are here. So is good X a normal good or an inferior good? That's the other question we have. is good X a normal good or an inferior good? First of all, what do you understand by a normal good and an inferior good? A normal good. What comes in your mind when you hear a normal good?
Hello?
Hello? Yes, sir.
Well, normal good. From what we remember, I think in microeconomics, these are goods where when income of an individual or a person increases, then they can buy more of that good.
Okay.
Yes. Then for the inferior good, this is where when an individual's income rises, or they have more, or if your pay is more, you choose not to buy that good which you were buying. For example, if I have no money, I would probably go for things, not bread, maybe go for sweet potatoes or
Jambos.
even vegetables, which are maybe chihuahua or something. But when I have no money, I would choose vegetables like spinach, those which are expensive, and go for the meat.
Yeah.
So those goods that you buy when you've got a lot of money or income, they are goods we call normal goods. Then those we choose to buy when we don't have money or more
Because we are
income.
stuck.
Yes, we have no option. Then those are inferior goods.
Okay. Thank you very much for that.
Things like cheese and bacon on bread, we only do them when we when we have money.
Okay. So those you only do them when you're fine, eh? When things are bad, you don't do that.
Tumadya chabeya ya jam so chap.
These things are bad. Okay. I have gotten that. I've gotten that one. So now, how can we tell using this question? Okay, using this question, how can we tell whether the good in the question is an inferior good or a normal good? How do we go about this question?
So now, since we found a positive answer, you said it's a what?
It was a substitute.
Yes.
You are referring to the previous question, eh?
Yes.
Mm. Mm-hmm. So, like for this one now we are dealing with the inferior goods thing. How can we go about it? What can we do?
In terms of what we are saying.
How can we solve this question? Like, how can we tell whether it's a normal good or a bad or a what or an inferior good? How can we tell whether good X is a normal good or an inferior good? What happens? How to go about it?
Maybe when income increases, it's just like when income increases, you buy more of that of the good. When income reduces, you are not able to buy that one. You switch to the other one, which is cheaper to suit your income.
Okay. So in context of this question, is this a normal good or an inferior good? Is good X a normal good or an inferior good? What does the class think?
For me, sir, I would say it's a normal good.
Sorry?
For me, I would say it's a normal good.
Okay. Why do you say it's a normal good? Okay.
Maybe to
Because
come in, sir.
Okay, let him finish, then you come in. Okay, you finish your thought because
yes, because of what we are explaining, when good Y increases, also good X increases.
that was about subsidy goods. We talked about subsidy goods and complement goods, right? We are done. Now we are talking about normal goods and inferior goods. How can we, is this good and inferior good? Good X. Yes, you can come in, Mr. Manza. You wanted to say something?
Yeah, maybe just trying, because I was thinking we found a 3 which was positive. So to me, this should be a normal good. Unless if it was negative, then we're going to say it's a substitute good. I don't know if I'm correct or not.
Okay, I get. We didn't conclude on this one. I think when we solved this one, we found the dy over the qx over the py, that it was positive what? It was positive 3. And we concluded that this is
Yes.
a what? A substitute good, isn't it? That was our conclusion. Now we are dealing with this question. Let me display the question that we are doing. That was question number 2A2. Now we have question number 2A3. It says, is good X a normal good or an inferior good? So it's a different question. You have to use a different approach. Okay, what helps us to determine whether a good is a normal good or a normal good?
I think elasticity of demand.
The elasticity of demand. Right.
On this one, I think
Wow.
specifically elasticity.
Okay. Okay. Thank you so much for all the attempts. So basically, when you are focusing, when you want to determine whether given a function like this one, you want to determine whether this good here is inferior or normal, you focus on income, okay? Because you're dealing with income. Just focus on income. So when you derive these, obviously you know that these will be constants. These will just be zeros. So, dqx over d what? dm, meaning we are differentiating this whole function with respect to m. You have negative 0.4, okay? 0.4. It's negative, which means there is a negative relationship between the increase in the changes in income and what? And the quantities demanded. You got that? There's a negative relationship. That simply means when income increases, the quantities of good X go what? Go down. You got it? Yeah. It's a negative relationship. So if income increases, the quantities of good X go down. And again, if income reduces, the quantities of good X go what? Go up. So now my question is good X an inferior good or a normal good?
It's inferior.
It's inferior, isn't it? So you see that when the income increases, the quantities of good X go down. Is that clear?
Yes.
Yes, sir.
If it were positive, you could have said it's a normal good because there could have been a positive relationship between good X and the income, which means when the income increases, also good X, the quantities of good X increase that are demanded. Does that help? Let's pick the other question now. The other question is saying, what is the price elasticity of demand at the current production? Wow. What do you think the elasticity of demand is? The price, oh, this is the price elasticity of demand. I like this one. This is powerful. What is the price elasticity of demand? And these are the questions that we expect to meet all the times. How can we go about finding the elasticity of demand? The price elasticity. Do you remember how to find the price elasticity of demand? We said, price elasticity of demand is equal to the change in demand, change in Q over change in what? In price multiplied by price 1 over Q1. Do you remember this formula? I communicated this formula in microeconomics, I think 3 years ago. Don't worry whether you can't remember 3 years, what happened 3 years ago, it's okay. You've seen this part that I've just highlighted. This is called change in quantity as a result of change in P. It's actually a slope, okay? It is a slope of this function. Now, since it's a slope of a function, this same part is same as the dq d what dp. Is that clear? Because it's change. Change in q over change in p is same as dq dp, right? So how do you find this part? This part we can use now calculus. We can use calculus to find this part, dq dp, or change in q over change in p. So that simply means we are differentiating. This is price of x. We are differentiating the whole function, q function, with respect to px now, okay? With respect to px. And you know that when you differentiate this function with respect to px, you get -4, right? Is that what you find? Yes, the derivative of the whole function with respect to px, it will just give you a -4. So this -4 is what you put here in the circle. Okay, so let's have -4. So you will have, hello?
I didn't see how you've reached there.
Okay, you are, don't worry, you'll be okay. I have said that this part, remember this is a formula that we use to find the elasticity, price elasticity of demand. So this formula is change the delta Q delta P. That's change in Q as a result of change in P. It is same as the, you can still rewrite this part as the dq dp. It's still the same thing. Now, when you bring dq dp, that's calculus now. You've employed calculus. Now, you and I, from business statistics, from business mathematics, we know that dq over dp is same as the slope of the equation, right? That's basically the slope or the gradient. It's the gradient of the equation. So the gradient of the equation, when you differentiate the function, like that's first the derivative, is what you call the gradient of a function. So the first derivative, or derivative number 1, is what we find when we are differentiating this function with respect to px now. So I've told you that you differentiate in the way how we were just differentiating all these things. These other ones will become zeros, apart from this one, which is px. So now, you just differentiate the way how we differentiated. That's how I got -4. You got it? So I've said now, this -4 is equivalent to, is same as this whole lot of this thing. It's the same thing. Does that help now? Hello? Did you get
Yeah.
it?
Yes.
Okay. If you have gotten it, then we are good to go. Then you multiply by the price of what? Good X. What was the price of good X that were given in the question? The price of good X was 200, isn't it? They said that good X sells 200 units. So the price of good X is 200. 200 divided by quantity. What was the total quantity of good X? You found the quantity, it was one what? 125?
125,
What was the
245.
245? Yes. So can you solve this? And then you should be able to find the elasticity. What's the elasticity? So 200 divided by 125, 245 is equal to that times -4. To find -0.006 64. Yeah. Seen it? It's negative 0.0064. Okay. That is the price elasticity at the current production. Now, is this price elasticity, is it inelastic or elastic? Is it elastic or inelastic?
Since it's in negative side, it's inelastic.
It is inelastic. Right. Okay. You still remember these things. That's right. Are we okay? So basically, I've emphasized that this part here is just as good as the first derivative, of the function. Derive the function multiplied by price of good X divided by quantity of good X. That's how you find, the elasticity of demand. Find the cross price elasticity of demand. Find the cross price demand elasticity of a change in the price of good Y. This is now a change one, right? Yeah. We just want the change in the price of good Y. So we want the change in good Y. That's how it changes. It's almost the same thing that we were doing, but now we are using the different goods. Let me just change the formula for you. Cross price elasticity. How does it work? So you will have dq dpy, multiplied by py over q, right? And of which I've told you that this is one thing. dq dpy is the derivative or the slope of the equation on the 3py in this case. So this will be positive 3 times the price of y is 15 divided by the same quantity 125. Was that 245? Then that will give you again the cross price elasticity of 15 divided by 125, 245, everything multiplied by 3. It's giving us this number is it's a positive number now, 0.00 another 0, then 3, 6. Okay. So this one is elastic because it's positive, right? Now, if the cross price elasticity is positive, you know what that means? It means that the two goods are what? They are substitute goods. Are they substitute goods? Yes, that is what we established even previously. So the cross price elasticity of demand is positive. Are you able to share, before we end this lecture, some of the factors which would determine the elasticity of demand of a product? Are you able to remember the factors affecting, the elasticity of demand of a product? Let's mention them quickly. What factors influence the elasticity of demand of a product? Number one. Hello, what factors are those? Have people left me alone? Hello, are people still there? We are ending soon, please. Just
Yeah.
gather
Yes,
some. Okay. What factors could affect the elasticity of demand?
One is the availability of substitutes.
Okay, yeah, availability of substitute goods, availability of. Okay, what about the other one?
The income.
The income. Right? Income. Do we have enough income? Then you find that that would determine how we respond to the changes in the prices, right? If you have income, like even if prices change, you don't complain too much. But if you are stuck, any other?
The price.
Sorry?
The price itself.
The price of the own good. How does that affect the price elasticity? Would you explain a bit how that affects the price elasticity of demand?
Maybe on that, when the price goes up on a particular good, customers will not would stop buying it and buy the other one.
So customers will respond, okay? They'll respond in some way by not buying. So basically it's just that. Then there is also the duration that passes, like the time period. So if there is a lot of time period that comes from the time the thing was introduced, you find that people start responding to price changes. But when some things are still new, people always, there is a certain way how people react to new things. Yeah. Does that help?
very much.
Okay. So don't worry, you will be fine.